We're working in intermediate algebra. This is section 6.5. We're in the middle of this section, so we're going to start with example 9 on page 247. All right, we've been working on graphing parabolas or quadratic functions based on shifts. So we're going to start with something now that has to do with the coefficient in front of x squared. All the shifts we did in the last video had a 1 for the coefficient of x squared, so they were the standard width parabola. So we're going to put in a standard width parabola here in red. This is the function f of x equals x squared. When we start changing this coefficient here, the coefficient is 1, so we have a standard width. When we start changing this coefficient, it affects how wide or how narrow this parabola is. So there is kind of a general rule that we're going to call this a. If the absolute value of a is greater than 1, then this parabola will be more narrow than the standard, which is this. If this coefficient a has an absolute value that's less than 1, this will be more wide. Okay, so since this coefficient here is a 2, its absolute value is greater than 1, this parabola will be more narrow. So we're going to draw that in blue, and it will just be more narrow. It will still have the same vertex at the origin. It will still open up. The only thing this 2 is going to change is that it makes this more narrow. This 1 represents the standard parabola with a standard width, coefficient of 1. This 2 is making this more narrow. The only way to really get this exact is to either make some kind of table of values or put this in your graphing calculator, which is later in this section, the graphing calculator. All right, example 10 asks us to graph f of x equals 1/2 x squared, and here we have the coefficient here that's less than 1. When the coefficient of x squared is less than 1, this will be wider than the standard. So we'll first draw our standard in red. So the standard parabola is here. We're going to mark that as just x squared. Our new parabola, since it has a coefficient of 1, its absolute value is less than 1, this will be more wide. So it has the same vertex at the origin. It's just wider. And again, like I said in the last example, the only way to really get this exact is to either make a table of values or put this into the graphing calculator. Example 11 is on page 248. We're graphing f of x equals -1/3 x squared. And again, here we have the coefficient that is not 1. The first thing I noticed, though, is that we also have a negative here. So we do know, we remember from the last video, that this negative causes this parabola to open down. Okay, so this opens down. And the 1/3 has an absolute value that's less than 1. So this will be wide or wider than the standard. So we're going to draw the standard in. This is f of x equals x squared. And then in blue, we'll put the transitions. The first thing I'm going to do, though, is I'm going to flip this down. So this should open down. I'm actually going to draw another red one. This is the standard width opening down. And then our new parabola is a little bit wider with the same vertex. So this will be -1/3 x squared. So two transitions here. First, the negative causing this to open down, and then the 1/3 causing it to open out wider than the standard. All right, example 12 says to graph f of x equals x minus 2 squared plus 3 and to give the description. So we're back to a coefficient of 1 here, so these will be the standard width, but we do have this -2 inside and a +3 or +3 on the outside. So if you remember from the previous video, if your transition is inside the square, this is a horizontal shift, and it will be the opposite direction. So this will be a shift to the right. And outside of the square is the vertical shift, and this will be a shift up. So these, we covered these in the last video, that the horizontal shifts are inside the square and they're the opposite direction of the sign. So not going to the negative, but going to the positive. So this will be a shift right. The vertical shifts are on the outside of the square, and of course they go with the sign. So we're going to go shifting horizontal right and vertical up 2, and that's going to put our vertex, if we start here at the origin, right 2 and up 3, we'll put our vertex here. So we'll put a point there, and we'll label this as the point 2, 3. That's our vertex. Does this parabola open up or down? There's no negatives here, so this is a standard opening up parabola. So we can draw it right in here, and it's the standard width because there are no coefficients in front of x squared that are different from 1. So let's do a little bit of labeling here. This is a minimum because it's at the bottom, and our axis of symmetry is there, goes right through the vertex, and the equation for that is x equals 2. Example 13 is on page 249. F of x equals x plus 3 squared minus 4. This is similar to the last example where we have a transition or a shift here inside the square. This is the horizontal shift. It's not going to go right this time though, it's going to go left. And our minus sign on the outside is going to be a shift down. So we're going to go left 3, 1, 2, 3, and down 4. 1, 2, 3, 4, and that's going to put us here at -3, -4. So we're going to label that as -3, -4. There are no coefficients besides 1 here, so this is not going to affect the width of our parabola, and there are no negatives, so this parabola opens up. So it's a standard width parabola. So this vertex is a minimum again. Our axis of symmetry comes down right here. The equation for that is x equals -3. Example 14 is at the top of page 250. It says f of x equals x minus 1 squared minus 2. So we're going to have from inside here, this will be the horizontal shift, and this will be a shift right, the opposite direction of the sign, and the -2 outside will be a vertical shift, and this will be a shift down. So we'll go right 1 and down 2, and that will put my vertex at 1, -2. There is no negative here, so my parabola opens up, and the coefficient is also 1, so we don't have to worry about any change in the width. So this is a standard width parabola. Our axis of symmetry comes down right here in the middle, and the equation for that is x equals 1. I also forgot to mention that this vertex is a minimum, not a maximum. Example 15, still on page 250, says f of x equals x plus 5 squared plus 4. So we're going to look for inside the square here is a horizontal shift, and this will be a shift left. Outside the square is our vertical shift, and this will be a shift up. And then we'll put our vertex in, first going left 5 and then up 4, and that puts us way up here at negative 5, 4. That's where our vertex will be. There's no negative here, so this parabola opens up, and there is nothing here to change my coefficient off of the 1, so this is a standard width parabola. So this parabola will look something like this. It does go off my graph, but that's okay. This vertex is at negative 5, 4. It's a minimum. The axis of symmetry comes, that's the wrong color, comes straight down here. And the equation for that is x equals negative 5. Example 16 is on page 251. It says negative x plus 2 squared plus 4. We have our shift inside the square, which is the horizontal shift. We have the vertical on the outside of the square, and we also have this negative here affecting the direction our parabola opens. So we're going to mark these. First, the negative tells me this opens down. We have this plus sign telling me this is a shift left, and we also have this plus 4 telling me this is a shift up. So first the vertex is going to go left 2 and up 4, so our vertex will be there at negative 2, 4. We're going to mark that as negative 2, 4. Because our parabola has this negative sign in front of it, this is now going to open down. So this vertex is not going to be a minimum anymore, it's going to be a maximum, because it will be at the top. So this is a maximum. And our axis of symmetry coming straight down the middle here. The equation for that is x equals negative 2. So always looking for this negative sign causing my parabola to open down, or inverting the parabola. All right, that's it for this section. Bring your questions back to class with you.